Hi class, welcome to Module 7. This week in our class, we're going to continue our discussion of regression. And what I want to do in this video here is I want to do one problem from your homework that shows you how to use StatCrunch to answer many of the questions very, very quickly. All right, so this week for you, what I have picked out is I have picked out question number 3 from your homework. All right, so it says for the set of data shown below, complete the following parts. So I have these x and y values here. And just generally, it looks like as x increases, so does y. All right, the first thing it says is find the estimates of b0 or beta 0 and beta 1, all right, or b0, b1 you can see. These are b0 is the intercept of the regression equation, and b1 here is the slope of the regression equation. So to find the regression equation, what you're going to do is you're going to click on these double pane windows here, and you're going to click Open in StatCrunch. All right, you've got your data lined up here. So you're going to go Stat, and you're going to go down to Regression. In this case, it's simple linear, so you're going to click right here. So for the x variable, obviously it's going to be an x, and the y variable, you're going to be y. So generally the questions you'll see as we get to the later parts are going to ask you to perform some type of hypothesis test. This is perfect how it's set up. Any question later on in the homework that asks you for a confidence interval of some type, you're just going to have to make sure to click this radio button. Right? But anyways, for now, let's just leave it as default. And I'm just going to hit compute. So you should see this printout right here that looks like this. Okay, you can see the intercept and the slope, and here is the estimate. Okay, these are the values that you're going to want to put in for B0 and B1. So to go back here, it says go to 3 decimal places. So the intercept here is negative 0.407 when I round it. All right, and the slope B1, all right, is going to be right here to 3 decimal places. So it looks like 1.779. Let's just plug that in. Great, we got it, all right? So compute the standard error or the point estimate for sigma, right? So SE. So that standard error, if you kind of like look at your output, see how it says estimate of standard error? Compute the standard error or the estimate for it. So that's what we want. And it says go to 4 decimal places. So this right here, the estimate for the standard error, 4 decimal places, is 0.3466. Right? So that right there, the estimate of the standard error is at S sub E. Great, we got it. Perfect. All right, assuming the residuals are normally distributed, determine the standard error, all right, for B1. So basically the standard error for the slope. Well, if you look over here, here's the slope. And here's where it says standard error. This right here is the value you want. So it tells us to go to 3 decimal places. So that's 0.0834 when I round it, or 0.084 when I round it. Right there, perfect. All right, so assuming the residuals are normally distributed, test. So that was that hypothesis test. Okay, it's a test to see if the slope is equal to 0 versus the slope B1 is not equal to 0. And use the alpha equals 0.05 level of significance. And it says use the p-value approach. All right, so I want the p-value to 3 decimal places. Well, if you look here, this right here is my p-value right here. It's the p-value for that hypothesis test. So let me go back and show you exactly what we ran. So look here, we said perform a hypothesis test to see if the slope is equal to 0 versus the slope is not equal to 0. That's just included in our output. Oops, sorry. So obviously you need to select the values there. So it's telling me that the p-value for this to 3 decimal places is 0.000. We got it. All right, so what does that mean? When the p-value is low, we reject the null. Okay, so it's either B or D. And you reject the null, it means there is sufficient evidence to conclude that some type of linear relationship exists between these two. When the slope is not When the hypothesis test says the slope is not equal to 0, all right, we can say that, then there is a linear relationship between the two. And we got it. So many of your problems this week follow exactly like this, right? Some might ask for a confidence interval, right? So instead of that hypothesis option, you click the confidence interval, but everything you need, all right, is put out in this table, in this output here, okay? If you have any questions, feel free to post to the classroom.